Welcome to Saitechinfo channel, my dear student. In this tutorial, I'll be explaining about a very important problem based on centripetal acceleration. Let us go through this problem. A stone tied to the end of a string 80 centimeter long is whirled in a horizontal circle. It means we are rotating the stone in the horizontal way with a constant speed. If the stone takes 14 revolutions in 25 seconds, what is the magnitude and direction of acceleration of the stone? First of all, we should be able to identify the parameters given in the problem. Here, 80 centimeter long string, that is whirled, so rotated. So it means the radius of the circular motion is 80 centimeter, and that can be converted into meter, that is 0.8 meter. And then 14 revolutions, so that indicates the number of revolutions. We can put it as n in a given time, that is 25 seconds. So let us say this is t. Now what is asked? The magnitude and the direction of acceleration. So this indicates the centripetal acceleration. So definitely we know the direction of acceleration, that is pointed towards the center. So towards the center, that is the first answer. Now let us find out the magnitude of that centripetal acceleration. So before explaining this problem, let us explore the concept behind this. See, when the stone tied to the string is whirled, that is rotated, what happens? There will be a inward pulling, and it rotates like this. O is the center of the circular motion. From A, the stone A goes to B in the circular motion and making an angle theta. So what is the angular velocity? Omega is equal to theta by t. And it may say that is in one revolution causes 2 pi length. So theta means here 2 pi radian. So 2 pi, and the time period for one revolution is capital T. So it can be interpreted as 2 pi by t. And this 1 by t is nothing but the frequency nu. Now omega is equal to 2 pi by t. So omega can be interpreted as 2 pi nu. Nu is the frequency. Now centripetal force is mv squared divided by r. We know V is equal to r omega. So V squared is equal to r squared omega squared. So we can substitute here and strike out r. Now we are able to get mr omega squared. So that is the centripetal force. So the force can be illustrated as ma, mass into acceleration. So since this is the force, this can be equated as ma is equal to mr omega squared, where we can strike out m. Now a is equal to r omega squared, and that is the very important equation to deal with here. As I already mentioned, omega is equal to 2 pi nu, and nu is nothing but number of revolutions taking place in a given time, t, n by t. So we can substitute a is equal to r into 2 pi n by t the whole square, and a is equal to r, we can substitute 0.8 to pi 22 by 7 into n. How many revolutions? 14 revolutions. So you can put 14 divided by t, given second is 25 seconds. So you can put 25 seconds. So that we are able to get the value 9.91. Here the unit is very important. So here A is equal to R omega squared. R, it is given in meter. Omega means radian per second. So radian per second whole square. So the actual unit is meter radian square per second square. And what about the so centripetal force, the magnitude centripetal acceleration, the magnitude of centripetal acceleration is 9.91 meter radian squared per second square. And what about the direction? That is pointed towards the center like this. Okay. Thank you for watching this video.